Good Test, 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 test. Can everyone hear me? Everyone can hear me? Good morning, everyone. How's everyone doing? Woo! I like that. I like that. Well, thank you all for being here. I know that the weather is coming in soon, so we all appreciate you so much for braving the beautiful sun right now, but we know it's going to start raining soon, so we really appreciate it. My name is Stephanie Chesson. I have the pleasure at working at San Bernardino Valley, and while I'm a communications professional, I do learn something new every year, like this is called the peduncle. I thought that was a fun word. So I put it on the shirt. You all get one, so make sure you grab your shirt. It's just amazing to see how many different organizations come each year for this event, and so we really appreciate everyone gathering together for this. First, I'd like to just do some quick thank yous. I'd like to thank the San Bernardino Valley Board of Directors for their support of this event each year. Their commitment is what keeps this free to everyone. So I just want to give a big round of applause to our Board of Directors. I'd also like to thank our generous sponsors for this event. They made the shirts available for everyone. They cover the hosted networking event tonight. So a big thank you to Esri, SWCA, Macmillan, Dudek, Aspen, Stillwater Sciences, Hannah Resources, Stantec, SurCal, and UCR. Thank you so much. Last, thank you all for clapping along with me. I'd like to thank our speakers, our panelists, our poster presenters, our planning committee members, our field trip tour guides. They have given their time and their expertise to make this possible, and we are so grateful for their contributions. So thank you very much. Please make sure to visit their tables. They all set up some awesome swag. Also, please go to the San Bernardino Valley table to grab some swag, because remember, the more you take, the less I have to pack up. So please, fill up a bag for me. So before we dive in, just a few housekeeping notes. No food or drink in the auditorium. The tables outside, you can leave your coffee and your water on before you come in. The restrooms are in the atrium right underneath the staircase. All breaks will take place in the atrium, and then lunch and tonight's networking event will take place across the street in the cafe. Just be careful if it is raining that you don't slip and fall. All right, so speaking of tonight, I did want to remind everyone of the hosted networking event from 5 to 7 in the cafe. This is also where our poster presentations will be happening. So grab a drink or two, no judgment here, and enjoy getting to network with your fellow symposium attendees, and check out the posters because they are awesome. So with that, I'd like to introduce San Bernardino Valley Board President T. Milford Harrison to the stage. Thank you, sir.
Thank you, Stephanie. Welcome to the 9th symposium from San Bernardino Valley Municipal Water District. We're glad that so many of you signed up. It is, I think this room's going to be totally full before we're finished. I think it only took 10 minutes for us to fill all the spaces. My name is Milford Harrison, and I do have the privilege of being the president of the board. There are several board members here that I will introduce in a little while. There is supposed to be a flag up on that screen, and there it is. Could you all please stand and join me in the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Thank you very much. And speaking of thank yous, I want to again thank Esri and our hosts, Laura and Jack Dangermond. They are such wonderful people and in such support of all of our environmental efforts. I also want to thank our staff, our CEO and Executive Director, Heather Dyer, who kind of keeps us all on the straight and narrow, except for Stephanie, of course. She's going to be with us this afternoon. She's at a presentation on behalf of our board and our district today. Stephanie has been so good in putting this together. She's in charge of anything that's fun in our district, and along with her sidekick who's sitting next to her, Jose Macedo, who is our chief of staff and clerk of the board. We really appreciate them and all of our staff members. There are so many members of our staff that are involved in putting this together and making it run smoothly, and we really hope that you have a great day today and tomorrow, and that we can all learn something and from these great presentations. And now it's time to get started with those great presentations. Again, thank you for coming.
Good morning? No? Okay, does this work? Yes? Microphone. Oof, it's dangerous. Okay, good morning, everyone. I'm Jennifer Alford. I am the director of the Institute for Watershed Resiliency at Cal State San Bernardino, and also an associate professor of environmental studies. I'm going to speak a little bit today about why we started the Institute and how it relates to climate resiliency, as well as some of the activities that our watershed fellows get to participate in. Big thanks to a lot of our partners, which I'll talk about in a second, and then some of our research efforts. So all collectively creating a giant feedback loop back into the topic of climate resiliency. So if you're not familiar with Cal State San Bernardino, we have 2 locations, and so that bridges a lot of really exciting work that we get to do. We're at the base of the San Bernardino Mountains in San Bernardino, so we have some great views if you want to come visit. But we also have a smaller campus out at Palm Desert. So our reach really represents the Inland Empire. When you look at the demographics of our students, they again really represent the IE. We have students that are first generation, typically coming with no roadmap whatsoever to the university system, or to even think about bridging their university experience into careers. So it's really exciting to be a professor because you become part of their family. You really become part of their relationships that they have with our partners, and it's really exciting to see them grow. And I'm going to stop here for 1 second because I first want my watershed fellows to stand up and just wave to you guys. Please ask them really hard questions today. So you'll see them around. Please engage with them. They're absolutely wonderful. Every year I'm just so lucky to have funding from San Bernardino Valley Municipal Water District, also from the Water Conservation District, Cucamonga Valley District as well, and then the Sierra Club, and they all, Mojave Water Agency, Karis will give me the eyes over there, which all are not only alum that I worked with before that are now in these agencies, but these are boards that have put dollars on the table. And as you can see from our demographic profile here, every dollar counts. Our students really do not have the capacity because of the different situations they're coming from to volunteer their time. And so putting these dollars down enables them to be working in a field and really training from the minute that they hit our campus and bridging right into the different agencies and nonprofits that we work with. I'd also like to give a shout out to all the Yodis out there. So if you graduated from Cal State San Bernardino or that you attend now, if you could please stand up for a second, because I really just want to show the depth in our fellows too. You're still students. Yeah, we've got a lot of Yodis out there. So Ryan. Yeah, so please engage with them. We're really excited about the work we get to do, and we really have an administration, which I know can be difficult sometimes on the campus environments, that are just absolutely supportive. So that's where a lot of this work comes from. So we used to be the Water Resource Institute. When I came to Cal State San Bernardino in 2017, a lot of people were retiring. The Institute in itself was really about our wonderful water archives, and that was great. But I was in the classroom seeing students come off third shift, Amazon warehouse, exhausted, really kind of struggling to make ends meet while also, creating their resume, right? Building their resume, building their network, building their expertise. And so really the focus of the Institute is workforce development, but it bridges service learning, it bridges environmental education, and that service to K through 12 and public settings, and also the research. So we created 3 programs. The first one's the Watershed Fellows. So again, harass them all day long. They'll be tabling. They have a poster asking really deep questions. But really, it's a year-long program, and sometimes we have people come in just for the semester. It really kind of ebbs and flows with the opportunities and what works best for them at this point in their lives. And the opportunities range from getting your CEQA certification to go out and doing bi-monthly or bi-weekly water monitoring, to going out and doing environmental education, you name it. And their days mimic a lot of ours. If you're like me, your car looks like a closet because you probably start off your day in waiters, and then by the end of the day, you're in a suit giving a presentation. So that's very much the type of experience that they get. And then we also have little smaller pockets of funding that we can do pilot programs with faculty and really get them engaged with all of you and getting the students involved as well. Our third primary program area is the Flows Field School. This is CSU-wide, and the idea here is getting different campuses together. We have 23 campuses across the state. We represent the largest public university system in the nation. And so this program really helps to bring students with different backgrounds, different interests, different disciplinary focus into the same space, and we learn anything from geospatial technology to monitoring, and we do that through our partnerships. We just finished our first round of Flows Field Schools out in the Coachella Valley, where we partnered with Agua Caliente, also partnered with the Audubon Society and did work with them, and then the Native American Land Conservancy. And our new baby, if you will, is our San Bernardino Mountains Lab. This is really in partnership with Valley District, San Bernardino Valley Municipal Water District, and the rim of the World Unified School District, which is a small school district, Title I, up in our mountain area. And so what we were learning is that and we'll hear this, I'm sure, over and over again today, is we need more monitoring. And so this was really kind of born out of the fact that we have a lot of students who are eager to learn, to get out there. They're hustlers, and I say that in the most loving way. But I was looking at a lot of agencies and nonprofits that said we just don't have the capacity to do it, but we need the knowledge. And so what this helps to do is to bring in students to fill those gaps. It's a win-win situation. But to make sure that it has generational longevity, we connect this into K through 12 education programs. And it says 700 here, but in the past couple of weeks, we bumped that up to, since August, 920 students served in the IE. And this isn't a tabling event. This is engaging activities like Project Wet, Learning Tree, and things of that nature. So it's helping to get us in the classroom and for those students to see themselves and our students. And it's really important to teach the pathways to education and the importance of stewardship. And so just some of the numbers, we've been around for 3 years now, so we're growing, and we want to keep growing, so partnerships is really vital to how we grow and what we can offer. But it just gives you kind of an idea that each one of these individuals is having an impact on multiple individuals, and so it's really starting to spread knowledge and also the idea of stewardship and involvement. Civic engagement's a really good piece. And then just to highlight a couple of our projects, this past year, Chris Jones and I were actually on the road on 210, and we come around the corner, and you'll never guess what we saw. We saw the line fire, the very beginning of it. We had just left a meeting with a group at Caltech, a lot of the staff with NASA, and we were able to reach out to them and say, hey, we've got a really good research idea. We'd love to understand the intensity of the fire and what happened. And so through their Develop program, which I highly recommend, you throw ideas out to them. It's a 10-week program. They put the effort and work and data into it. We were able to understand more about the intensity and compare that against prescribed burns. And then this is our monitoring effort. The green dots are stuff that we do biweekly, so we have nearly a decade of data associated with that. And again, you can ask at the poster session. Our fellows will give you some snippets of that. And then the blue is kind of where we're trying to expand more into the Santa Ana. And along with that monitoring comes imagery. It's really important for us to start collecting imagery of our sites, understand riparian health, how stream flows change over time. So we're creating that, but it helps to tell a story. And that's really where the engagement of the community comes in. So these are just a couple of examples of how we're able to see those changes in headwater streams over time, which are so vital to our communities. And then lastly, we're at Esri, so I got to give a plug here. We take that data, and instead of it just sitting on an Excel sheet in my computer, which could happen to any of us, it happens a lot because time passes very quickly. We put it into a Survey 123 tool, and then we actually use that in a dashboard environment. So our longer term goal is to put this in a public facing environment, and it can be used to inform a lot of the work that we're all doing, trends over time, connect it with climatic changes, and really start to think about resiliency more holistic. So not just the data, but how we tell the story, and that we're creating even archives every time we are collecting this data. So I welcome questions. I don't know if we have to have a minute. Okay. We have, if anyone has a quick question for me, please, raise your hand. But really, the point of all this is that climate resiliency takes on a lot of different looks. It really creates feedback loops that we can all invest in, even if it's just your knowledge or your time. That is the life-changing type of work that we're seeking to do. And then we're also seeking those resources for students, because again, having those resources enables them to help build the capacity that we all need in our work.
Hi, Jennifer.
I haven't given you a hug yet.
I know. I saw you from far away. I already emailed you while you were talking, but I thought I'd ask the group because I think it's an important question. I'm wondering how those of us that work in private industry or other entities that aren't currently collaborating might find different ways to connect with you and the work that you're doing in support of the students and kind of continuing the cycle.
Absolutely, and I did not mean to leave the private sector out there. You're obviously very key to this. I mean, it's anything from coming, letting us go out and see your site projects and teaching us the techniques and the methods and your procedures that you use, to how you guys actually got into your jobs. I think that's really a mystery for a lot of students. They look at job descriptions and they have no idea what it means. So any kind of engagement opportunities, even if you're not local, Zoom works. Those are vital. And I know Lindsay's a great example. She does a lot of fantastic trainings. So carving out space for our students is really what's going to keep this machine going. Thank you.
Let's see. Can I work the clicker? No. The green goes forward. There we go. Cool. So, hello, I'm Nate Butler. I'm with Stillwater Sciences, and today I'll be talking about the holistic environmental approaches to promote climate resiliency and sustain aquatic ecosystems. Deep breath. Big words here. So, we all understand that watersheds are changing. Climate change, land use, revitalization efforts in a lot of our watersheds, increases in water recycling to promote water resiliency, and modifications to urban stormwater runoff. And environmental flow approaches can promote climate resiliency because they can assess how these changes will affect conditions, our aquatic ecosystem, and importantly, our goals. The key thing I'm going to talk about today is the California Environmental Flow Framework. And it's a holistic, integrated environmental decision-making approach that uses the management goals as the key for deciding what the flow recommendations would be. The key thing about this is that it's all about what are your goals? How do we use flow to help support them? It began development in 2017, building off many different environmental flow approaches, and then it was officially introduced, rolled out as a technical guidance document in 2021, and importantly, it was developed collaboratively. It had resource agencies, it had academics, it had the state water board all involved in it. So that way it basically had all those different perspectives and used all that information to try to come up with a way to streamline the process, make it transparent, and make sure that people understood how to go forward in it. And so I'm going to talk about one very specific example of SEF for the LA River, and hopefully emphasize how lessons learned from that and how we've been applying in the LA River can potentially also apply to the Santa Ana River. And in the LA River, we're trying to understand what river flows would best support watershed goals into the future. And we have a very different set of conditions across the watershed that we have to consider. And so we have to understand a method that would be able to address all of those. And the first thing we had to do, one of the key things that this is all about is what are the goals? And we had to look in all these different planning documents to understand what have people gone through community processes, take advantage of all that information, and understand what have people said they want the river to support. What recreation, what tribal cultural, biodiversity, flood risk, urban cooling is especially important going into climate resiliency, water supply and water quality. How are those things influencing goals? And then we basically took advantage of all the things that people are planning to do, because things change, and this is what this is all about assessing. We went to LA River Master Plan, other plans out there for the lower LA River. We had the Arbor project that's looking at redesigning a lot of the river. And we went through and inventoried all those changes and basically said, okay, how can we classify channel bottom changes? How can we classify channel wall changes and overbank to come up with ways to basically understand these individual changes and uniformly look at it together? And then we basically built 3 main scenarios. And this is just the starting point. Existing, of course, obviously. But then low implementation is what would be occurring if the most likely to occur projects advance forward into the future. And then high implementation, what would be if people like really reached for it? And so like concepts that aren't really even developed would be taken forward. But this gives us a starting place to look at bookends of what is our future going to look like? How can we make sure we're planning appropriately for climate change? And so then we took those existing and planned conditions, put them into GIS. So we have existing conditions here. Let's see if I can do this right. Existing. Then we started adding some projects. Then we kept adding more for high implementation. So that's the key distinction between these. And something that's not shown here is changes to water supply and how that would likely change. But those are also taken into account under low and high implementation. But then we can basically translate that into what's our hydrology change in models, what is our hydraulic change, flow, depth, velocity, other conditions, how vegetation would potentially change. And that allows us to assess conditions and basically come up with results that are spatial and can basically see very clearly like what's the frequency of suitable days for steelhead adult migration. Under existing conditions, it's way too fast. Under low implementation, it makes big leaps forward. And under high implementation, we see slight differences because it's different projects, different ways that the channel form conditions are changed. And this allows us to basically see into the results and understand what are the flow ranges that can support those goals. And then, the key thing for environmental flows is coming up with that flow recommendation. We're designing a hydrograph to best support goals. So here I've listed a handful of goals: kayaking and wading, nature exposure, that's a really important one that you gotta think about. Tule adults, steelhead migration and adult lamprey migration, and then basically ask, what would be the flows during wet season? Thinking from an operations perspective, what would be the flows during wet season that we would want to have to best support these goals? And we can repeat that for every single season and functional flow, that's the key part of the SEF, to understand what would a hydrograph look like, how can people operate to best support these goals going forward. And sometimes you get really lucky, and you can look at each of the flow ranges for individual goals and find a flow range that exists for all of them. But in many cases, you won't. In many cases, there needs to be some form of channel form refinement to basically shift the channel to better serve the goals for the available flow. Sometimes you can change what flow is coming to the river. How do stormwater improvement projects provide flow to the river? How does it basically potentially change how long flow recedes? So we get a better recession peak, because in the LA River, we're really flashy. In a lot of SoCal, we're really flashy, and more so than historically. And one of the more controversial, but still something that we have to keep on the table, is goal refinement. In some cases, our goals are really ambitious, and that's good to think about that. But maybe we can think about, like, well, what's the core time period? Maybe we change it so it's variable in the different water seasons. In some water years, we would support the goal for a longer period. In some drier seasons, we would support the goal for a less period. But what's the essential time period and core period to look at? One of the important things to think about is also goals that are not supported by any flow range are likely due to channel form conditions. In the Ellery River, we have a lot of concrete. You're not going to get willows and tule in a concrete environment. So in some cases, it's a non-starter. It's not flow that's the key thing, it's channel form and revitalization of our rivers. But this tool, the modeling, can be used to explore how these things change over time. We can understand, like, okay, now that we have this tool, we can think about alternatives. What if other projects went in? What about other changes in hydrology? What if our storms change? And how can that be promoting our goal achievement into the future? And so the key outcomes of the Ellery River CEF are going to be seasonally variable flow ranges that best support achieving our watershed goals into the future. And we'll have a list of potential actions that can better support goals and an improved understanding of where more actions might be needed. Because again, spatially explicit, we can really get into the details. And so that will give us an ability to ask those questions and plan for the future. And I want to give a shout out to all the people who funded this, especially City of Los Angeles, the Mountains Recreation Conservation Authority, and California Department of Fish and Wildlife. There have been tons of people contributing their time, but they have really stepped up and supported this work, and it would not have happened without them. Thank you. 2 minutes for questions. Christian.
Nate, how do you think about CEF? How does CEF apply to rivers that are? Gotta get mic'd up first. I gotta get. I've got it. Wait, people get to pay attention to me. This is great. How do you think about CEF in ephemeral sections of the river, and thinking about when you have that transition from a fully flowing condition like you do in the LA River to ephemeral, and what are how does CEF thinking about functional flows help that?
So CEF and the way that we're approaching it is reach-based. So we're actually allowing different reaches to have different conditions, and this gets into a technical detail, but CEF divides the river based on where tributaries or other inflows come in. And so we can basically say, like, okay, this reach might, under certain conditions, under maybe average water year conditions, go dry. And we can make that explicit recommendation of, like, this is the natural hydrology, and this would be supportive of native species and potentially beneficial to biodiversity by creating that range of habitats. So it breaks it down that way, and we can look at it and accommodate ephemeral reaches in addition to perennial.
Yeah, how does the discharges from the city's wastewater treatment plants, the recycled water flow, affect your study?
It is one of the key components. Like, this all started because of the push for increased water recycling and reductions of flow to the river. And essentially, it was a question of, like, okay, what is this doing? And there was interest in understanding how it is better serving our goals, or maybe in conflict with our goals, and how can we go beyond that and basically find ways to accommodate the need for increased water recycling and still get the biodiversity, recreation, and urban cooling conditions we really want. So it's like absolutely key. It's like the central component of it.
Hey, Nate.
Hey, Wendy.
So can you describe some of the recommendations that would come out of the CEF process for the LA River?
So there are a handful of different recommendations, but one of the key things is, I would say, the hydrograph. So we're going to have different flow ranges for the individual reaches and the different seasonality. So, like, basically when you switch from a wet season to a spring recession, and how to shift and alternate between those, and allow potentially for maybe changes in water recycling or other water usage during those time periods, but also taking into account the water year type. And so you would basically have the idea of like, okay, if we have this much precipitation, we should be supporting a wet water year type hydrology. And if there's less natural precipitation, then we should be supporting more of a dry water year type hydrology. In addition, it's basically going to say like, okay, these areas, if you want to achieve your goal, because you've said this is a goal in plans that have gone through community review, you should put in a project to achieve that goal. This has been underserved, and this needs more help. And with that, I'm out of time. So on to the next person.
Hi, everyone. Good morning. My name's Mia Ashby. I'm a master's student at UC Riverside in the Anderson Lab. And today I will be talking about the thermal regime impacts on Santa Ana sucker development. So if you remember last year, I had a presentation similar, but we were just going over our proposed methods for this project. So this happened actually right after the conference last year. So I'll be talking about our first time using these methods. Okay, so our study species is obviously the Santa Ana sucker. As many of you know, it is a federally threatened species. It was listed in 2000, and it's very fragmented where its range is now. It's in the Santa Ana River, the Los Angeles, the San Gabriel River, and the Santa Clara River as well. Although the Santa Clara River population is not included in the listing because it's thought to have hybridized with the Owen sucker. It's facing many threats. There's tons of invasives. The water is warming in the river. There's lots of wastewater treatment plants that are releasing warmer water into the river, encroaching urbanization. And so this species is facing increasing threats, especially with climate change. The river is warmer than it's ever been. And it's crazy because we really don't know a lot about this fish. There's only been one study studying their life history at different temperatures. It was done in 1970, and it was actually done on the Santa Clara River population. So the guy, Greenfield, in his study says, well, this may not really be applicable to the other populations because there's all this stuff about people think that that population could have been introduced, and there's people arguing about if they're hybridized with the Owen sucker, so who knows. So anyways, there was a huge need for us to know more about their life history and how we can conserve them in warming temperatures. And so shout out to the Palm Springs Fish and Wildlife Office. They provided our funding. And so we were hoping to address at least 3 recovery goals for the species. The first being water quality. We wanted to determine tolerances to variations in water quality, specifically thermal fluctuations. Find out how we can ameliorate hydrological modifications to mimic natural flow regimes, and identify conditions conducive to spawning, including thermal ranges for egg viability. So the main questions that we wanted to address were, what is the Santa Ana sucker's thermal lethal limit? And then if we are able to hatch them, what do the larval sucker eat in a hatchery setting? Because we're hoping to continue to do more studies, but we don't know how they work in a hatchery setting. Most fish that are already hatched in hatcheries, they have like protocols, so we just wanted to figure out, how do we build this? Okay, so this is kind of what I talked about last year. Here is our tanks that we house the fish in. So we had 6 fiberglass tanks. They were housed at RCRCD. And each tank has 2 sections. So there's this big section that has all of the cup replicates. And then there's this sectioned off part here. And this has a pond pump, an air stone, and then a heater and a chiller that are set to a specific temperature. And each tank ranges from 10 degrees Celsius all the way to 35, so they go up in 5 degrees Celsius increments. And then the pond pump with a PVC pipe pumps water into these little pipes that add flow to each of the cups to make sure the cups have enough flow. The cups are hung over the edge of the tank with gardening wire. And then this little thing here, shout out Tevin, he designed it. It's our larval nursery. So once the fish were large enough to be able to swim across the water column in these little cups, we moved them to the larval nursery, and then we started feeding them either a random selection of Artemia, Odahime, or ground algae pellets, just based off of what they're already fed in the raceways as adults, which is they give them algae pellets once in a while, and then in other hatcheries with other suckers, they use some of those other items. So we wanted to see, do they eat this? What do they prefer? And we did have 2 phases. So the first one, like I said, started right after the conference last year. It was the end of February. And we wanted to start with the raceway fish to have the least impact on the wild population. So we squeezed all of them for the eggs and the milt. And we actually had a 0% hatch rates, major fail. We realized that we did something really bad. None of us really had hatchery experience. And we didn't know that you can't expose the gametes to water before fertilization, which sounds funny because like you think, okay, they do this in the water, you know, whatever. But there's actually a very short time window from when the eggs and the milt are released in the water to when fertilization can happen. So actually none of our eggs were fertilized at all, which sucked. So we waited a few weeks, nothing happened, and then it was already late in the season. The hatcheries had already had all their larvae, so we were like, shoot, okay, we need to go to the wild population. We electrofished. In April, we got like 60 fish, squeezed all the females, no eggs. So we were like, okay, shoot, should we do this again? We did it again 2 weeks later, squeezed about 50 females. One gave us 1 clutch of eggs. So we were like, okay, let's just do it. You know, at this point, let's just go for it. So we had about 150 eggs spread across 6 temperatures, which is not ideal, but we tried it. So this is what happened. So here on the x-axis, we have temperature. So these are just the bins of each temperature tank we had. So in the 30 and 35, we had 0% hatch rate. All the eggs died. 10, it actually looked like some of the eggs were potentially developing, but in the end, none of them did. They all died. And then in 25, our warmest tank with survival, we had a pretty low survival rate, and that was because in the beginning of the project, I had to remove about 2/3 of the eggs due to a fungal outbreak. So that one ended up being pretty low. And then 20C did the best with 84%, 15C had about 77%. And then here we also have temperature on the x-axis, but this is only the 3 temperatures that had survival. And then we have weighted mean days till hatching on the Y. So 15 took the longest. It took about 8.5 days to hatch, which is still way faster than we thought. 25 took about 3 days, which was crazy. Like, we did not think it was going to happen that fast. Something else that we saw was the distribution of hatch days, the amount of days the whole replicate took to hatch. That also decreased as the temperature increased. So for 15, it took about 3 days for the entire replicate to hatch, and 25 was only like 1 or 2. And then in this graph, we have days since hatching on the X, and then we have larval length in millimeters on the Y. And we, again, have only the 3 temperatures that had successful hatching. So the 25 did the best. It still continued to grow the quickest. The 20 didn't do bad. The 15 grew significantly slower. So we thought it was pretty clear, at least in this experiment. The 25, they did well. They hatched very fast, but there was kind of a trade-off with potential fungus outbreaks because it's warmer. And we actually had a spinal deformity in that temperature. And there's hypothesis that in the warmer temperatures, the sucker can have spinal deformities. So we only saw one, so we don't know a ton about that. But that was interesting. And then finally, here we have a log-log fecundity relationship with the females. The fork length is on the x-axis in millimeters, and then the egg count is on the y. So as the fish, as their fork length increased, they generally had more eggs. But if you look at this graph here without the log scale, most of our females just had no eggs at all. So over the course of both studies, we only had 4 females that had a full clutch of eggs. There's a few here that had like 1 or 2 eggs. Maybe they were like at the beginning or the very end of like when they were going to release their clutch. But for the majority, we just couldn't find the time when most of the sucker were gravid. So that was like a huge issue for our project. So for future directions, we think that the fish may develop past 25 degrees because from 25 to 30, that's a huge jump in temperature. But we only had 6 tanks. They're really expensive, so we just need to figure out how we can get between those temperatures. So we think that they probably won't hatch past 30 degrees. But again, grain of salt, this is only 1 replicate. And the gametes cannot touch water before fertilization. And then the raceway sucker were gravid earlier than the wild sucker, but both seem to have a pretty wide range of readiness. So for our next steps, we want to begin gamete extraction earlier in the season, do it at regular intervals so we can try to pinpoint the time when when most of them are gravid. They have a super wide range. It can be from like January to July, so there's no way we're going to get them all at once, but at least a significant majority would be ideal for our study. And then we want to investigate temperature and weather conditions leading up to this hopeful happening event so that we can find out, okay, if we want to do this again, and just what are the cues for this to happen. And then we would like to hatch them at additional temperatures between 25°C and 30°C to really pinpoint that thermal lethal limit. And then a sneak peek, we're doing the study again right now. We started it a lot earlier. We do have more eggs. It's going pretty good, and we ended up taking off our 35-degree tank, and we added a 27.5. So we'll share the results with you soon when we get that. But thank you for listening. Thank you to Palm Springs, Carlsbad Fish and Wildlife Office. They were a huge help. Everyone at RCRCD, the fish experts, thank you. Thank you for all of my undergrads. My lab mate, Ria, she's going to present. My PI, Kurt Anderson. And everyone else that helped. So let me know if you have any questions. Thank you.
Yeah, it was great. Sorry if I missed it. So fungus, it growed at what temperature exactly more? It was used throughout the 77, I think the 85 degrees.
So we had a couple random incidences where like an egg got fungus. It happened we had like one at 15 and we had like one or two at 20, but the big majority was at 25. So we're not sure if this happens in the wild or if it was just something that happens in the hatchery. Like I've talked to other hatchery professionals and they all deal with fungus even after treatment. But we did adjust our iodine treatment this year, and we're actually seeing a lot less fungus. So I think part of that was also just due to our iodine treatment. I don't think we did it long enough. But from what I hear from other hatchery professionals, like when you're trying to do this with a new fish, it's really hard to figure out all these small steps and like getting it right for every fish. So, but yeah, the majority of it was at 25°C.
Great, thanks. And sorry if I missed it. So the fungus was bad for the larvae in general?
Yeah, sorry, I didn't explain it. So the fungus basically just killed them. Like if the eggs had fungus on them, eventually, I don't know the whole process, but it will kill the eggs. And what's worse is it can spread very fast. So as soon as you see it, you need to remove it because it could take out your whole replicate. There was one instance where I think I had the picture up. The larval fish had fungus on it. And I'm not sure if the fungus attacked it after it died or if it died because of the fungus, but most of the fungus happened at the egg stage. Oh, okay, one more, sorry.
I just have two questions. One, did you simulate at all any diurnal variability in temperature, or did you keep the temperature constant?
We didn't, but I would really like to do that in the future. I think for now, we're just trying to get a baseline, you know, like what is their lethal limit? But ideally in the future, that would be like ideal next steps, like, because that's, you know, obviously how it happens in the wild. But no, we haven't yet.
And then my second question was just, was there a relationship between the growth rate and the actual size, and then did that total size affect the fertility or the number of eggs?
The growth rate between like the size of the
So like how quick, if it grew more quickly, did it also become larger, or did it become smaller because it was growing rapidly?
Oh, they became larger as well. Like they grew quicker and were still larger at the end of the study.
Okay. And then, but they had lower fertility if they were larger and grew faster, or there were fewer eggs?
So the fish that grew the fastest and were the biggest, they ended up going back into the raceways. So we maybe have gotten eggs from them this year, but we don't know. They kind of just all get mixed back in the raceways. But yeah. Okay.
Thank you.
Thank you.
Good morning, everyone. Is it fine? Hope you all are doing great and enjoying the symposium today. I'm Riya Ghosh, a fourth-year PhD candidate from University of California, Riverside. And today my topic of discussion is assessing spatial and temporal variation in size spectra of benthic macroinvertebrates in the urban Santa Ana River. So as we all know that the benthic macroinvertebrates, or in short BMI, they are the small aquatic insects which are good indicator of the water quality because the community changes rapidly with the environmental conditions, its gradients. So it can be spatial, it can be temporal, or both, right? So for studying the BMI community dynamics in the urban Santa Ana River, I am using a bioindicator which is called size spectra distribution. The size spectra is the quantitative relationship between the body size categories and the abundance of biomass of those individuals. So we are using this bioindicator because size spectra gives insightful information for both ecosystem structure and functions which are important for the conservation and management purposes. So according to the metabolic theory, it can be stated that in warmer environment, the system tends to have more smaller size organism due to greater per unit mass metabolic rate, so growing faster, small generation time. So it is represented with a steeper slope of the size spectra distribution means more negative slope, while in the colder environment, we tends to get more larger body-sized organisms in the environment. So it is represented with the shallower slope means less negative slope of the size spectra distribution. So from the previous study of the Santa Ana River for the BMI community, we have already found on the left side box plot, if you see on the x-axis we have all the sites, and on the y-axis we have the richness, that across all the sites, the BMI richness is fluctuating. So the pink color sites are basically the sites which are near the wastewater treatment plants, and the all other sites which are in green, these are away or downstream of the wastewater treatment plants. So now on the right-hand side line plot, if you see on the x-axis we have the time, and on the y-axis we have the species richness. And across the 12 months data, the species richness across all the sites, this is also varying for the BMI community. So each line is representing each site and the variation of the species richness across the 12 months. So these results already indicating that the community dynamics is fluctuating spatially and temporally in the system already. So on this ground, my research questions are, first, do the size spectra distribution of the benthic macroinvertebrate community differ between effluent and non-effluent sites in the urban Santa Ana River? And second, are differences in the size spectra distribution consistent across seasons or not? And I hypothesize that due to the differences in the environmental parameters, the size spectra pattern may vary between the effluent and non-effluent sites, and also it is expected to vary across the seasons. So here in this map, you can see all my sites from where the samples were collected across over the 12 months. So the sites which are written in orange, these are the effluent sites or E sites, means near the wastewater treatment plants. And the sites which are written in green, these are the NE sites or non-effluent sites away or downstream of the wastewater treatment plant site. Now, after collection, we have identified it up to the genus level, then individual length was measured, and these individual length was converted into the biomass data with the help of Benke's length mass regression relationship. Now I am using this biomass data to estimate the size spectra distribution by using size spectra package in R. So for the spatial variation, I have individual size spectra plot for each site. So for each plot, we have body mass categories on the x-axis. Each green beans are those categories. And on the y-axis, I have the counts for those categories. And on the left top of each plot, the site is mentioned here. Here, and then on the right top, the slope B is mentioned with the confidence of interval. So for the Rialto side, we have the slope minus 1.82. For the Rig side, we have the slope minus 1.31. For the RWQCF side, we have the slope minus 1.69. For the sunny slope or SS side, we have the slope minus 1.67. And here, the Rialto, RICS, and RWQCF, these are the effluent sites. And the SS and all other sites, these are the non-effluent sites. So for the ARA, sorry about that. For the ARA side, we have the slope minus 2.16. For BRA side, we have the slope minus 2.19, sorry, minus 1.91. For the AMS side, we have the slope minus 1.87. For the B-hole side, we have the slope minus 1.72. And for the average slope, we have for the non-effluent sides, more negative means steeper, means more smaller organisms in the sides. And for the E sides or effluent sides, we have shallower slope, which means more larger organism in the sides. Now for the seasonal pattern, starting from the winter season, the slope is minus 1.68. For the spring, we have the slope minus 1.85. For the summer, we have the slope minus 1.68. And for the fall, we have the slope minus 1.58. So the initial assumption is that we know that we have in the here that wet winter, lots of pouring, lots of flash flood. So basically, we get less amount of samples, and also there are some larger organisms who can withstand within those events. So that is why the winter slope is a little bit shallower. Then in spring, when the water gets warmer, the juveniles are growing. So more smaller organisms in the environment. That is why we are getting the steeper slope. These juvenile cohorts in the spring basically getting larger. So in summer, we are getting more larger organisms in the system, so shallower slopes. And in fall, we are getting the shallowest slope here because in the BMI community, we get many larval stage of different flies like caddis flies, dams flies. So it seems like it is the emergence period from them, so they are out of the system. And who are left, they are larger organisms, larger body size organisms towards the adulting. So we are getting in fall the shallowest slope here. So for the summary, with the first question, do the size spectral distribution of the BMI community differ between effluent and non-effluent sites? We didn't get any significant p-value, so the size spectra pattern is consistent between the effluent and non-effluent sites, but they varies across the seasons. So for the future direction, I will keep studying more explicitly site season-wise size spectra pattern, and we'll try to understand what environmental parameters are basically driving those patterns. With that, I want to thank my advisor, Dr. Anderson, and all my lab mates and everyone who helped me with this project. I want to thank all the organizers, sponsors today, with all the listeners for your patience and cooperation. With that, I'm happy to take any questions. Thank you, everyone.
Hey, are you able to look at whether those slopes are driven by specific taxa? Like, can you look at one taxon that was found at all of your sites and see if those size spectra are consistent with the patterns you saw overall? And would that be another way of looking at your hypotheses? Yes.
I mean, we were working on that presently. So basically what we were getting initially, that it's a turnover of different species. So that is why basically, as you have seen, that we are not getting any pattern for site-wise. So it is the species turnover of different species according to site season-wise. And yes, there are many dominant taxa for particular sites. It's very much site-specific what we were getting, and that's why we were trying to understand the pattern and the drivers.
Yes, did you have criteria for choosing your non-effluent sites? And if so, what was that criteria?
Oh, so basically for categorization of effluent and non-effluent sites, in effluent sites, the wastewater treatment plant is releasing water there, so temperature is warmer there. rather than the downstream because it's getting mixed. And also like there are the pH, conductivity, these are like, because the nutrients are it's getting poured there, so like low pH, extreme pH, high conductivity, low dissolved oxygen in the effluent sites, why it is kind of getting recovered in the non-effluent sites, how much it is getting distant. So that's how we have categorized.
I thought it was supposed to be a panel. Hello. My name's Christian Broderick, and because I'm not speaking at this conference, I get to ask other people questions. And so that's my role up here today. And I'll be looking at my phone not to check for messages from people, but instead to remind myself what questions we were going to talk about. And then we'll just pass the mic, and we'll have some time at the end for questions from the audience. So today we're going to be talking about climate resilience, and I was just going to ask each person to say a few words about who they are. We heard a lot about who Jennifer is, but how their work is affected by or informs how we think about climate resilience.
Great, thank you. Yes, Jennifer Alford again, Cal State San Bernardino. Really, as I mentioned in my presentation, when I started this position and talking to a lot of people that are here today, the big gap was the monitoring and gaps in that knowledge. And so while there was a piece here, a piece there, we didn't really have continuous data, so it's really difficult to make decisions and to really kind of model and project what the future may look like and how we can better position ourselves to be proactive instead of reactive. So really at the heart of my work is headwater streams. That's where my love is, my passion, and I really feel like as someone who embraces the value of hydrology. Really, if that top tier of the hydrologic network is impaired, then it's really difficult to think downstream about how we can mitigate those. So really kind of my jam, my sweet spot is getting students to help us all understand what's going on and to really build that capacity and then the knowledge and really create knowledge hubs to where we can all be interacting.
Hi, everybody. My name is Monica Burnett. I work for the California Department of Fish and Wildlife. I specialize in native non-game fish. So in the areas that I work, most of those fish are either state or federally listed under the environmental, and under ESAs. And so a lot of the work that I do is in a management capacity, but a lot of the species that I work with are disproportionately affected by climate change, and so climate resiliency is an important topic for those species.
I'm Nate Butler, and I primarily focus on hydrology and water quality, especially temperature. That was one of the main things that I did in previous iterations of projects. And so climate change and climate resiliency is a critical factor of many things that I do, and a lot of it is all about, most of my work is all about trying to understand conditions to better achieve goals that people have: water supply, biodiversity, recreation, urban cooling. Those are themes in the LA River, but those cross all boundaries and are things that we all want to know about. And climate resiliency is basically all about trying to promote the conditions that would connect the wetter and cooler regions and features that would better support those goals. Because if we have those, then we have more resiliency to the change. We have the ability to use those as refuges in a way. And so a lot of my temperature work is, what are the refuges?
Hi everyone again. So I'm Riya Ghosh. fourth year PhD student from Anderson Lab, University of California, Riverside. So as I have already mentioned that I'm using a bioindicator for studying community dynamics of benthic macroinvertebrates and native, non-native, all the fishes also there in the system. And I work in the critical reach where basically the Santana sucker is living. So we all know that the water, like wastewater treatment plants, so that reach where I work, basically 85% of the water flow comes from the wastewater treatment plant release. So what happens, the wastewater treatment plant is not only changing the water chemistry, but also it's modifying the habitat. So it's multiple stressors. And when we study the interaction of the multiple stressors, we all know that it's really hard to understand the patterns, what's happening in the environment. So that is where I work. I'm using the size spectral distribution to understand, to pinpoint the particular site and season-wise, which is less vulnerable and which point is more vulnerable, so that it will be easier for the conservation and management people to prepare, to withstand, recover, and for long-term goals, basically, so that I can give that information to them that in which place, particularly, what is happening there.
Well-deserved applause. The next thing that I sort of struck me in advance when looking at what people were going to talk about was that we're talking about things at a variety of scales, right? Ria's going and measuring things like at specific spots within the river. Nate's talking to us about how to think about the LA River as a whole. Monica's working across Southern California, and you are like taking over the Inland Empire, the empress of the Inland Empire. And I was just wondering, how do you think about climate resilience at the scale you work at? Is it important for you to scale that down or scale it up to think about resilience and climate change? And yeah, I didn't really know how to finish that question, but that's my question.
Yeah, scale's really important, and I guess for me, I'm kind of in this spot where my heart and my work is in headwaters, and so it's really interesting when I take students out and I talk it up, right? I'm like, oh, headwater streams are so important, and then they're going and seeing this little trickle of a stream, and I'm like, it's really important, But I think what I have to be mindful of, because I rarely say no, because I'm just so enthusiastic about all the work we're doing. I mean, people reach out, I'm saying yes, yes, yes. But I think one thing I've learned over the past couple years is I can, there's certain scales I can work at, and I can do it really well. And so for me, that's why the headwaters are so important. That's something tangible that I can be out there on a really regular basis. But in my mind, when I'm doing that, and as I write up the importance of the work, it's the downstreams communities that are so reliant on this knowledge. And so a lot of my work, whether it's been in the Inland Empire or other reaches of California, has really thought about the disadvantaged communities, the tribal communities, a lot of the longevity of these water resources and what it means across generations. So even though we work in small little, watershed pockets, yeah, really the scale is not only, over time and space, but it's also, thinking about how in one reach it can really impact a lot of people. And so I kind of, physically I'm at a smaller scale, but the impact of the work that we're doing is at a larger scale.
For a lot of my work, I tend to consider climate resiliency in general, but climate resiliency specifically across habitat range. For each of the individual species that I have, they're occupying in a restricted range. And so this concept of monitoring the resilience of the habitat, it's really important for each of these different locations that these species are in. It's really varied, but sort of across each individual species range.
So I think about scale all the time because of how the question that's being asked determines the scale that you need to address. And so for water managers who have to manage large districts, it's all about like the larger scale. What is the overall net? But for a lot of the resource agencies and the people who do the regulation, it's about small scale. And so you have to be able to move between scales and understand like, well, what are the implications in a small scale? What are the implications in a larger scale? So that way you can address the different priorities of the different groups. From a recreation urban cooling perspective, it's all about like, what is the access to the person who's going for a walk? And you have to recognize that is a very valid, important scale for them. And for, I would say, BMI and everything, it comes down to how like, well, what's the food web for the species that you're trying to ensure has the resources it needs to survive warmer conditions where more food can actually allow them to survive. And so like, it's all about scale dependent and selecting the appropriate tools for the questions being asked.
So I think for my work, scale, I mean, it is very important scale dependent, as you said, that it's, I'm studying at the finer scale because as 85% of the base flow is coming from the wastewater treatment plant, so the flow is highly dependent on when they are releasing water, how much they are releasing water is just not depending on the seasons, right? So we have in the system periodically, like cyclic way, periodically dry and wet period. And that's why we have sometimes too much disconnection, pockets, which adds more stressors into the system. And as I am working in the critical habitat for the Santa Ana sucker, so it really makes for them hard to survive within those particular pockets, because then maybe, I mean, there are different factors it can be increased, like negatively impact on those threatened species, just like more predation pressure, like who are trapped within those pockets, and escape routes are like totally closed, right? So, I mean, these different kind of scenario can happen, and that is why climate, like resiliency for my system is very much important for the conservation purposes.
Wonderful. The next question I had is inspired by how I think about Southern California habitats, which is that in Southern California, habitats tend to be really fragmented, maybe more so than many other places in California, California has done amazing things to our landscape to make it not work right. But I was wondering how you think about habitat fragmentation on your particular study or your interests, and if there are ways that that habitat fragmentation can be mitigated. Should we start with Ria first, because she's at the other end?
Yeah, so yes, as I will just continue where I finished, that we already have, like the habitat is highly fragmented because of the water flow. So I want to address that thing, that due to the habitat fragmentation, as you have seen from my presentation, that for the size spectral distribution, we are not getting any patterns, right? It's consistent. We assume that it can be a reason for the habitat fragmentation because it's the consistent level of species turnover, like whoever can survive there, something like that. So they are, because it becomes day-to-day survival or the dynamism of the system, right? So that is how, still now we are getting the seasonal patterns, but as we will look more about the site and seasonal patterns of the site spectra. So that is how my, like the fragmentation is basically impacting my work, I believe.
So fragmentation for a lot of my work, in my perspective, is all about how do we support rivers and waterways doing their natural functions. They cross the entire landscape. They provide the cooler, wetter conditions that allowed habitats to be connected. And so a lot of this is trying to understand how we can basically revitalize, restore areas that reconnect the habitats, like selectively. Like we only have so many resources, we only have so much time to basically dedicate to these things. So it's all the question of how can we basically target areas that would best connect things. And there's a lot of interesting connectivity work being done in the LA River watershed and all around California that goes and looks at these key connections and asking, can we restore something here that would open up other habitats and move them and undo that fragmentation? And that's a lot of really interesting stuff and builds climate resiliency.
Habitat fragmentation has a major impact on species distribution and species migration, and that's one of the biggest, I think, issues that a lot of my species face. I can give a focal species, the Santa Ana speckled dace. When you have all these major weather events and like massive wildfires, you get huge changes to the systems that can blow those fish out of that habitat that they were in. And then you get these fragmented areas where you've sort of got perennial water in the headwaters and then ephemeral reaches below that point that tend to go dry in the summer, where there's not the connectivity windows that allow them to migrate back up into that area, or if there's if there's barriers preventing them from getting back up in there, it really impacts a species' ability to stay on the landscape. Habitat fragmentation is huge, and looking at where we have solid perennial habitat versus ephemeral is a big thing that I've been working on recently to sort of help these species maintain their range, maintain their distribution.
Yeah, wholeheartedly agree with what they've all said, and we all feel the same in the room. Habitat fragmentation has been detrimental, not only to so many species, but also how we interact with the environment and the landscape. And it's, you drive the Santa Ana, and it's just mind-blowing how you can go just a couple miles and you're looking at something completely different than what you saw upstream. It's also interesting and important to realize jurisdictional boundaries play a big role and why we see the landscapes that we do. And so I will give a shout out to organizations and efforts like the Headwaters Resiliency Partnership, where we're all trying to sit in a room and figure out how we can better work together and connect our vision together about what that looks like. And every landscape's different. We're all dealing with really different complex things. I work in the Headwaters region. We don't have a defined municipality. So when our streams are flowing, it's flowing through people's properties, and they do all sorts of weird, wacky things. And so it's challenging in the sense of we all know we have to address it. We all want to address it. But really getting the stewardship mindset is a challenge, and seeing the vision that we all have.
Thank you. I just wanted to check on that. How much time do we have left? We're good. What time are we going till? Okay. I can just keep talking. All right. I want to just make sure that we save time for questions, so if you can give me a warning about that. Okay. And the next thing that it's sort of been a personal evolution for me, I guess, and so this is why I wanted to make sure we covered this, and you, of course, just talked about this, is the effect of the work, the kinds of work we all do on people. I've been, it's very tempting for me sometimes to just bury myself in when does that rock move, and not think about what the effects of that rock moving have on the humans around us. And various people I work with are constantly reminding me that we need to think about people. And so that's been in fact, one of the most satisfying parts of my job. And I just wondered if each of you could address that topic in some way, and how you think about that, and go from there.
Yeah, Yeah, the greatest moments in my life are when a student says, aha, they have that light bulb go off and they start seeing themselves as part of positive change, whether it's just through learning something, getting hands-on, or careers, interacting with so many of you and saying, that's what I want to be when I grow up. And I ask students that when they start our program, and they kind of stare at me for a second, and I'm thinking, what do you want to be when you grow up? And really the purpose of the process that we have at the Institute is for them to try a lot of different things and figure out what they definitely don't want to do. Many people come out and say, I want to do field work, and then, after standing in the rain for several hours, they're thinking, desk sounds really great. But hands-on is how I got into it. I sat through so many classes with hundreds of students in it, someone just standing at the podium running their mouth for hours, and me trying to write the words down as fast as I could and take notes. I don't remember any of those teachers. I remember the teachers that took me out and really started to engage me in their research and their work. And that's why us all working together and creating those moments creates, again, generational change, but also institutional change in how we approach the work that we do.
Yeah, and I'll echo some of that. One of the big difficulties of working with non-game species in particular is that in general, people, friends, family, they don't even have any idea that these species are living in the areas that we're with. They don't have a way to ascribe a value, whether that be intrinsic, aesthetic, or even economical, to the species. And so it tends to be a lot of really passionate people that I work with, a lot of, many of you in the audience that that are the driving force behind a lot of the work that I do. But one of the things that I would like to incorporate into my program in the future is more community involvement, because I think that getting people to understand what's out there, getting them familiar with the different species, that's going to be a really big driver in the future of being able to conserve those things. So, you care about what you know.
So I'm usually not the person who gets to talk to people. I'm behind spreadsheets and computer screens most of the time. And so I don't get to talk to the community as much. But when I do, I really am trying to emphasize the connections between our goals. And the LA River very much has shaped how I talk about this, but this has been an interesting theme that I've seen throughout of how biodiversity, recreation, urban cooling, flood risk management, water supply, water quality, these are all things that people care about, and they're all very connected. And being able to talk to people and help them realize that we have to coexist, and getting to see people who have previously been at odds in the room together in technical working groups, working together to basically answer those questions has been really inspirational. And I've seen this sort of transformation happen for the LA River, where people really are all talking about, like, okay, how can we make this better for all of our perspectives? That's pretty awesome. And that's the thing that I love the most in a lot of respects.
So I will kind of summarize what they have told. So my message, I want to give a message that investing on the environment is investing on us for our future, right? And that message needs to be delivered through the mass awareness campaigns. Like, I strongly believe that who are studying, we know what we are doing, we have our motivations, we know why we were doing that and what will be the implications for that, right? We are investing. But the problem comes when it's about the public support, because I think there is a communication gap between us and between them. And I know there are different types of levels and layers, that's why we cannot do it. I just want to mention here one example. So I'm from India and a metropolitan city, Kolkata. So when I was a kid, there was a huge hurricane named Ayla, but our city didn't get affected too much because we have a delta near the Bay of Bengal. So that portion, basically the mangrove saved us. saved our city. So that's what happens. They are our protector. So that message needs to be delivered not only who are studying, who are working, but also to the common people, as you said, that relating with their daily life, that what they can do for us. And that's why we were working.
That was awesome. We have a few minutes to open up for questions for the audience for any of our PAM. 10 minutes to open up for questions. Oh my gosh. So hopefully you came loaded. We can fill in time if you need to. Oh, I see a question already.
Hi. I am sort of thinking about the out of the box here. From what I've gathered from all of your presentations, the Santa Ana River is going to keep getting hotter. And so I'm thinking about pathways for mitigation. Do you think it's far-fetched to consider the implementation of water cooling facilities at effluent discharge sites, like some sort of cooperative plan or agreement between water treatment operators and water quality management agencies? I imagine that money would be a barrier and that several small-scale studies would need to be done before large-scale implementation of this. But I just wanted to know your thoughts on this.
So yeah, I mean, I agree with you about the monetary thing, like that barrier for us. But I think what is doable, that more monitoring. And then, for example, if I say where I work throughout the stretch, there are many riverbanks which are like not of soil, it's like made up of sand and something like that. So basically the recovery after any like flash flood or that kind of event, its recovery rate and speed is really low because, I mean, everything is washed out in the system, right? So that is a problem for the communities, biotic communities, what we have. So what we can do through monitoring, at least, I mean, so climate resilience is not about like we will recover to the natural, like to its original state today only. It's not about that, right? But through monitoring, we can identify those particular spots where we can stabilize the banks, plant more trees so that we can have the river shade, and the communities, fish, benthic macroinvertebrates, they can reduce the heat stress during the summer because we have the dry summer here, right? And another thing I also think that if we can deeper the system, it can create refugia and it can increase the depth so that also more deep, cooler space when there are repeatedly dry and wet season, like this frequency, then this can reduce the stress as well for the biotic community. So these are the two examples that we can use for mitigating these adverse effects that I see, but I think there are many other ways also if you can identify and just start with that gradually, one by one, then it will be really helpful in a long process.
And I agree with everything you said. And the one detail that I would add to it is I've seen some analyses of how much energy and greenhouse gases chillers would use, and they're just not going to be effective in most locations. Nature-based solutions, as much as that is a buzzword, but trying to get the planting, trying to create a healthier riparian ecology is, in the long run, a lot more cost-effective and likely to give us the information and the better coexistence of different goals for biodiversity and water supply than a chiller. It's costs too much and so much energy.
Any other question?
Jennifer, you had mentioned that a lot of the headwaters are in private property, and I just wanted to ask, what has that engagement looked like in terms of including private property owners as stakeholders in headwater resilience?
Yeah, absolutely. So living in a mountain community and not being from there is the first challenge. It took years for people to say hello. What's really interesting is my relationship with the community was born out of a visit to my dentist. And I know that sounds crazy, but we started talking about water. Turns out that this individual is insanely active, arrowhead water, things of that nature that have been going on in our mountain range. And having a simple conversation opened the door to a whole community that I would have never engaged in. Or had that level of engagement in, as coming in as a friend and a community member versus an academic. That has splintered into just learning. The people I meet and what they do in the small communities I live in are just mind-blowing. And a lot of retirement, people who are retired, their history is really important. But probably one of the biggest things I can take away from it is that a lot of the community members are generational. And so the history of what they've seen on the landscape and their experiences have really been what's opened the doors to things like the school district, being able to go in and speak to that. And it's connected the younger generation with an older generation. So the storytelling, people bringing up photography and pictures, photos of what it used to look like has really been the gateway in. So, engage with people, say hello, and I know that sounds really simple and simplistic, but that's, just being open to that and showing up. I tell my students constantly, just show up. You never know who's going to be there and who's going to have that conversation with you that's going to lead to a whole different world. Had that not happened, there's no way I would be in the position I am now.
Excellent. We've got time for one more. Oh, yeah. Any other questions from the audience for our panels? For our panel?
Students out there, do you guys have questions?
Oh.
Hang on 1 second. Yeah, my bad.
Hello, my name is Maria. Hello, everyone. What would be the ideal way, since some of you are large scale and small scale, of collaborating with each other if all four of you were to meet and come up with a plan for water resiliency, climate resiliency, any of that sort?
I don't know about too much collaboration, but I can say that as I'm working in providing the information, so that can be a good resource for me, and I am happy to do that. And also I want to mention that I'm using a bioindicator, and okay, so let's mention that. Why I'm using the bioindicator? Because it's giving both the ecosystem structure and function information. Normally what we see, there are many indicators like Shannon diversity or studying food web structure. These are kind of separate things where we have to study for getting the information. But for my bioindicator, we are getting the information together from there, so we can use it to pinpoint the vulnerability of the system, and then can think about more, according to this information, think about more how to think about different strategies to have the climate resiliency gradually for the long time sustainable development.
Email, email, email. Meet in person at symposiums. But basically talk to people all the time. That's been my biggest thing, because I know one very small specific element of hydrology and water quality, but I don't know a lot of other things. And so I basically email people every time, and I fully admit, and I apologize to some people, Mia, I've emailed you, and basically been like, I don't know this. Do you know anything about this? And then I just basically go around to try to find someone who's got the time. That's the key thing in my mind, is trying to find the person who has the information and the time to help out. persistence.
Yeah, so a lot of it is just having these conversations with each other, and when we find this common ground of projects or points of interest that we're looking at, there's a lot of opportunity for overlap and a lot of opportunity to work with each other as partners. I mean, I've met Ria out on the Santa Ana sucker surveys that are done by the San Bernardino Valley Municipal Water District, with USGS and RCRCD. And so those kind of talking to people, asking questions, pooling our collective knowledge is also really important. But just, it takes time, and it takes opening those doors for communication, but it's going to look differently in terms of like maybe all four of us working together. I couldn't say how we could get something like that working, but I have already partnered with a lot of people out here, and there's a lot of opportunity, a lot of overlap. Stillwater Sciences has worked with CDFW and Cal State San Bernardino as well. It just takes finding somebody with a common goal and starting those conversations. It's huge.
Yeah, I'll say that this symposium is a really great example. I mean, if there were a mission statement or objective, that would pretty much be it. Getting us all in the room, getting us to start having conversations and networking. And there's never a dumb question. I think a lot of people are scared to reach out and ask a question to someone, so just ask. And if they don't know someone, I guarantee we could sit in this room and connect everyone somehow very quickly. We have such a wonderful network of people, of willing participants who are happy to connect. And, everyone that supports and has been here throughout the years has seen it grow. And so sometimes I get questions about fish from students, and I go like this, and I said, but I know someone. And so following that trail and being, again, persistent, the showing up, being persistent, and if someone doesn't immediately email you back, it's okay to email them again. It's not being rude, it's not being inconsiderate, it's just sometimes we get bombarded with stuff and we miss it, and that's not any reflection on your effort. So just really, just being like continuous in your questions and asking, and it all gets linked together. There are a lot of efforts around the Santa Ana and other representative watersheds that in California that have just really set the stage for frameworks nationwide. So you're in a great spot. Utilize those resources and knowledge.
Thank you.
Thanks, that was great. One more question.
Hello. I had a question directed more towards Monica and Nate, representing California Department of Fish and Wildlife and Stillwater Sciences, one federal organization and one private organization. I want to know what types of certifications or career-related specialties you look for when looking for coworkers or other parts of your team members.
Yeah, so with myself at the California Department of Fish and Wildlife on like a state level, a lot of entry-level positions, the main thing that we're looking for is just your willingness to go out and do the work, the passion for it, the ability to work with people in field settings is something really important. Having the knowledge is, of course, always really important, but there's lots of ways to sort of get involved, and it really varies depending on the department that you're interested in working with. I work specifically with fisheries, but we also have habitat conservation areas, we have wildlife areas, and if you have the knowledge and expertise for those specific areas, there's some really great opportunities to get in there.
So the key thing that I would say I always look for in people is willingness to learn and keep learning, but also organizational skills. I work in a lot of spreadsheets. Anyone who's been involved in my projects know how many spreadsheets, and I try to shield people, not too much. But there are a lot of spreadsheets that I have to look at. And being able to be organized and very methodical in how you present information and thinking about how you can communicate the key points, that's a skill that I think is always in need. Trying to find someone who can get to those key points and take their expertise, their really specific knowledge, and be able to answer the question in an organized fashion to the person who needs. Like, I email and be like, I want to know about this, and then being able to communicate that key thing that I'm asking in a clear, concise way and allow me to ask the follow-up questions is super useful across the board.
Thank you.
I'll follow up with that and say that the thing I most look for in an interview is enthusiasm and passion. And just like, you know, I like to ask people questions like, why do you like maps? And what is it about that hillside that's pretty? Or, you know, that makes you think? And then just to get a sense of how people see themselves in the world. All right, I'd like to thank the are you going to say this?
I'm going to thank you. I'm going to thank all 5 of you. Thank you very much for your time and your attention and your knowledge. And I think I need to talk with Jennifer a little bit later because I'm still trying to decide what I want to do when I grow up. And I think she's got some good input on that. We're ready for a break. There's some snacks and so forth out in the lobby, and we'll be back at 10:20. I want to do something that I failed to do earlier, and that's tell you who the other board members are that are here today. Gil Bateo, who is our vice president, and Jose Velasquez is one of our board members, and our longest serving board member, Susan Longbill. We appreciate all that you do. Thank you, and enjoy your break.